Hi, welcome to the pre-calculus lecture series. And we are still in the unit about functions. So for this video, we're going to cover section 2.7, is combining functions. So we're going to introduce several function operations can help you to combine the functions. And the most important concept in this section is when you combining functions, right? So what will be the domain after you combine them? That's the one thing we need to pay extra attention to it. Okay, so it's the domain concern. Okay, so now let's go to our lecture notes and see what type of the things we're going to cover here. Okay, so here we go. Okay. So the combining functions here. So the first things here, let's take a look. So the first combining function, let's take a look at the simple way to combine the function. We call this the algebra of functions. So what I mean, the algebra of functions. So basically, just like if you give me the real number, how do I add, how do I subtract, how do I multiply, and how do I divide, right? So it's the same thing for the functions here. So let's see here what that means here. So if like I have two functions, right? So I have f and g, right, will be the functions. And with domain A and B here. Like I said, so we need to be very careful here. So let's be color coding here. So F here has domain A, and function G here has a domain B here. All right. So now we said when we like we said, a combining function is just like we do with the number. You can add two numbers, subtract two numbers. So we do the same thing. So we said if you say f plus g, right? So if you have f plus g, x, so basically this is the way, it's the same thing, like you write fx plus gx here. Because this resulting function is f of x plus g, so the resulting function, the domain here, has to be what? Has to be the same domain as the A intersect B's, right? So don't know if you guys still remember these notations. What do we mean this notation? This notation means the intersections. So what is means intersection? That means and, right? So that means both A and B. So that means the domain has to satisfy both because the resulting function, you combine the both. So the same way you can do if f minus g, the f of x is here. So this will be same like f of x minus gx, right? So the same things here, domains here has to be what? The same between A and B's, right? So the same ways here, if you see a notation like f of gx, so that means this is f of x times gx here, right? So the domains here also, because you need to satisfy both function, is the A intersect B. And the last ones here is if you divide the f of gx here, that means basically you divide the f of x gx. So this is just the notations here, right? Okay, so here, the domains here, we need to be careful here. Okay, so the domains here, of course, all the x's here has to belong to A intersect B because this is the resulting functions here, right? But now in here, take a look here. Because the gx right now is on the denominator, so what do we need to do? We need to add one conditions here, right? So we need to add one, that means all the value has to belong to both A and B. Yeah, that's given because the resulting function. And also we need to know the gx is what? It's not equal to 0, right? From the previous section, we know, if you have a fraction, then the denominator cannot be equal to 0. That's why we need to add this notations here, because the the notation, the denominator cannot be equal to 0. So this is pretty important, right? So don't forget about that. So if you put the f of x on the denominator, that means then you need to exclude the value for the f of x equal to 0 here. All right, so now let's take a look. The first ones here. The first example is pretty easy here. So they said, let's take a look at the f of x and the gx, right? So before we even start, let's try to write it, see what is the f of x, the domain here. Let's just list here. Domain for f of x, you guys still remember if x 1 over x minus 2, so what is that? So it's all the x in the real number except what? Except x cannot be equal to what? Except x cannot be equal to 2, right? So that means x not equal to 2. Or if you want to, maybe instead of using the word here, you can say it this way. So it's all the value in the real number, but x is not equal to 2. Maybe that's a little easier to read instead of, the wording here. Okay, now the domain of the gx, right? So the gx here is what? Is everything, because it's the root function. So the everything has to be greater than equal to what? Greater than equal to 0, right? Okay, so now let's try to find the first things here. Okay, so let's try to do our, okay, so we have the domain there. So the f of g, f plus g, x, so will really just be the 1 over x minus 2 plus what? Square root of x, right? Okay, so the domains here we say has to be both, right? So it has to be greater than 0 and not equal to 2. So let's try to solve what is this domains here. So we say the domains here is for all the x has to be what? Greater than equal to 0, and x cannot be equal to 2, right? So that's what we said, it has to be both. Okay, so now let's take a look at f of minus gx, right? So it will just be the x minus 2 minus the square root of x. So this one's here is the same thing. The domains here has to be greater than equal to 0, and x is not equal to 2. All right. Okay, so now f times g is here, right? So let's see here, f times gx is here will just be 1 over x minus 2 multiplied the square root of the x, or you can write it like this is the square root of the x minus 2. Okay, so what happened here? So this one, the domain, also the same, right? So this is x greater than 0, and x is not equal to what? Not equal to 2. Okay, so now let's take a look at these ones here. Be careful here. F of g x is here, right? So f of gx, so it will be 1 over x minus 2 over square root of x. And if you simplify a little bit, it will be 1 over square root of x minus 2 here. Okay, so the domain, right? So we know the domain will be x greater than 0 and x not equal to 2, right? But also we need to exclude what is the value for make the denominator equal to 0. So what is this value going to make the denominator? The gx equal to 0 is x equal to 0. So I need to exclude these values, right? So I know my common is x greater than equal to 0. So in here, I have to say is x greater than 0 and x is not equal to 2. You see here? So that's why I need to only have x greater than 0. The reason why I need to exclude that is because what? Because then this one will give me the denominator will be equal to 0. That's right. Okay, so now let's take a look. Let's say find the 4, right? Okay, so that means that I'm going to find the f of g to the 4. What's that mean? That means you just plug the numbers. So this is the 4 minus 2 plus the square root of the 4. So this is 1/2 plus. So this is 1/2 plus 2, right? So this is 5/5. Okay, so the same thing, f minus g to the 4. So this would be 1/4 minus 2 minus the square root of the 2. So it's 1/2 minus 2. So this will be negative 3/2, right? So f of g, times 4 will just be what? The square root of the 4, 4 minus 2. So this will be 2/2. So what is here is 1, right? Okay, so last one here is f of the g, x is here. So, you know, the 4, right? So the here, this will be the square root of the 4, then 4 minus 2. So this will be 1/square root of the 4, all right? Okay, so this is the first type of the combination of the functions is pretty straightforward. The combination of the functions, just like that's what we call it, the algebra of the function. How do you add, subtract, multiplication, and the divisions here, right? So the next ones here we're going to talk about is the composition of the functions. Okay, so the composition of the function is how to compose it two functions here. So what is the composition? The first, let's take a look at the notations here, right? So in here, so we say that given two functions. Okay, so the given two functions, f and g, all right? So the composition functions, we use these notations. So we say this is f, right? So this is, we use this notation like f little 0g. Okay, so we also call, so also we also say that this is, we also call that this is what a composition of f and g. All right, and we defined this is a very important notation. So we say f of the g of the x's here, right? This will be defined as f of gx, right? So this is a kind of this is what is the notations here, right? So be careful. This is we call this a composition. So we use this little 0, kind of little o, and so that means the order here is f composite g. That means the gx here you need to go first. Okay, all right. And now in here, okay, so if you take a look at the picture, so basically you have two functions, right? So this is, I call this kind of like the g functions, right? So this is the g functions here, right? And then this is what we call this, the f functions here. So you have some input here. So you get an x here. So it seems like you go to an oven and then you cook it the way you like, and then when they come out, then you bring to the f functions here, right? So whatever come out, the things that come out here, right? So you say, okay, the things that come out here is gx, right? Then you bring the gx to the f function oven, then to see after you bake it, what is come out here, right? So that when it come out here, that's what we call the, this is, you know, you bake again in the F's house and with whatever your gx is here. All right, so that's what we call is a composition of the functions here. Okay, so like we say, the mathematical part is pretty easy. But then the domain part is really, we need to be careful here, the domain of the composition of the functions here, right? So because we are involving like two functions here, right? So let's take a look at the domain. This is very important top, so the domain of the F composite G, right? So G is, so it's the set. So the first things here, right? So it's the set. So this is the set, okay? So this is the set that all the X in the set, in the domain of G first, right? So because G is inside F of X, so the X has to be in the domain of the G, and such that, such that the G, right? Such that whenever you come out of the GX, and has to be in the domain of what? Of F of X here, right? Okay, so it's in the domain of the F of X. So basically tell you, so let's say that in other words, so what is the composition, like F composite GX here is defined, right? So in other words, it's defined, okay, so it's defined whenever both GX has to be defined, right? Because it has to satisfy GX and F of GX, okay, are defined here, right? Okay, so so that's why the domain of the GX is here. So let's highlight the keyword here. So that means all the X has to be in the domain of the G. Then after that, then all the value of X has to be in the domain of the F of X, right? So this is a very important concept. And I really like, so here, let's take a look. This is the graph. I think it's a pretty good graph to demonstrate what is the values here, right? So we said, so I have an X value here, right? So first, let's see here. So we defined that this is my functions, right? So I said, okay, so this is my G function. So as we know from the function, so that means I defined a GX here, right? And then from here to here, what I have here, I have F functions here. Okay, so this is the F function. So this is that means I'm defining F of GX, right? So it's kind of look here, right? So here is the domain, right? So this is the domain of what? This is the domain for the G. And now the G is here. This will become the domain for what? For the F here. Did you see here? Okay, so now that's basically is kind of like you can define the function you directly combined from the X to here, right? So from the X to here, this is what we say is F composite G here. Okay, so that's the F of F, right? So that is, right? So it's very important, right? So we're going to do some of the problems. So make sure we understand how to find the domains here, right? Okay, so let's say here, find the composite functions, the composition of your functions, and find their domains here, right? So here, let's take a look here. Let's first find the composition of a function. It's pretty easy. It's very mechanical, right? So let's see here that we just need to write it out correctly. So this is F of the G. Okay, so F of the G, that means G is go inside, right? So what is GX is X minus 3. So that means you plug the GX, right? So here the GX is x minus 3, right? Okay, so this is x minus 3. Now, that means everything in the f of x. So this is become x minus 3. So that means everything in the f of x, the x has to be replaced by the x squared. So these ones here will become x minus 3 to the square. All right. Okay. Now let's see here. The next one's here, the G composite of F here. G composite of F, that means F is inside. Okay, so now look at what is the F is inside in here. You say, okay, the F is inside, so F is x squared. All right, so now I can say this is G, the x squared. Okay, so now that you see, okay, this is x squared, that means everything in the G with x has to be replaced with x squares, right? So this will be the x squared minus 3 here. Okay, so now let's take a look here, right? The domain, okay? So the domain of the, let's see here, the domain of the F is what? Is the all real number, right? Because it's x squared, no restriction. And the domain of the GX is what? It's all real number also, right? So we said, because of the domain of GX is going to have the all real number. So then the domain of the F composed of the G also is what? Is all real number, right? So the same way is here because there's no restriction. So the domain of the f of x is all real number, and then you put into domain of G. So we know the G composed of the f is also is all real numbers, the domains, right? So this is the domain. Okay, think about it, right? Okay. Okay, now let's take a look at part B here, right? Okay, so the part B is here. F composed of the G to the phi. Okay, so remember, this means F of G to the phi. Okay, so G compute first, right? So G to the phi is here. Okay, so what is G phi? Okay, so let's see here. G to the phi, that means phi minus 3 equal to what? Equal to 2, right? So this is G to the phi here, right? So it's equal to 2. So that's why you say, okay, so this is equal to f of 2. Now, f of 2, you plug back to the f of function. So it's 2 to the square. So what is the answer? Answer is 4. Okay, let's try again. For the G to compose of the f, right, to the 7th here. So that means G, the f of the 7. So what do you need to do first? Hey, I need to find the f of the 7th, right? So I need to find the f of the 7. So let's see the f of the 7. So you use the f function. So it's 7 to the square. So what is here? So it's 49, right? So you find the f of the 7 here is 49. Then you plug back to the G's, right? So this is G to the 49. Okay, now what is the G function? Is x minus 3. So it's 49 minus 3 is equal to the 46 here. Okay, so this one is pretty straightforward. Let's take a look at a little bit of complicated one. Okay, so now if the f of x is equal to the square roots of the x and the gx is equal to 2 minus the square roots of the x here. Okay, so let's try to write down the domain here separately. So the domain for the f of x has to be what? X greater than or equal to 0, right? Then the domain for the g of x, because 2 minus x has to be greater, 2 minus x has to be greater than or equal to 0. That means x is less than or equal to 2. Okay, so now let's take a look here. Okay, so I'm pretty sure the mechanical one, so we're pretty good at it. Okay, so f of composed g, that means f of the gx. So g is inside. So what is g? So here is 2 minus x. right? So it's 2 minus x here. Okay, so that means now you need to plug the 2 minus x. So this is 2 minus x, right? You need to plug back to the f of functions here. Okay, so this one's here, it will be equal to the square roots, right? So then this is the square roots of what? Square roots 2 minus x, right? You just, what is in here? So you just plug in the x equal to square root of the x. So this one you can simplify is 2 minus x to the fourth roots, right? So this is the fourth roots here. Okay, now let's take a look, right? So what is the domain? Remember the domain has to satisfy the gx first, right? So gx, the domain for the gx is x less than or equal to 2. Okay, so x equal less than or equal to 2, and also we need to satisfy, you know, the f of x, right? Okay, so the domain for the, okay, so the domains here is going to be, right? So it's given the x here, because in here, right? So this is the composite function. So domains here is 2 minus x has to be what? Greater than or equal to 0, right? So that means, what is the domains here? That means x here is, so this is 2, is greater than or equal to x here, right? So that means it's from the negative infinity to 2, right? Because, you know, this is the final functions, right? So inside f composite g, that's why I said f composite g, because this is even roots, right? So I need to say it's greater than. Okay, now let's take a look at the next one. So maybe this one, if it's still not very clear, let's take a look at g composite of f, right? So g composite of the f, that means f go inside first, right? Okay, so the f of x, so what is f of x? It's the square root of x, right? So the f of x is greater than or equal to 0, right? So that's the first condition. This one has to be greater than or equal to 0. Now you plug these ones here back to the gx here, right? Okay, so this will be equal to what is the square roots of the 2 minus square roots of the x. Okay, so now, you know, the first condition, because so here, look here, right? So look here, the gx here, f of x is here, right? The domains here, what is the domains here? We said domain is x greater than or equal to 0. This is my first condition. But I also need to satisfy my second condition. That means it's in here, right? So I know, okay, so now let's take a look. This is 2 minus square roots of the x has to be greater than or equal to 0. That means 2 has to be greater than or equal to the square roots of the what? Square roots of the x here. So you take the square roots, take the square both sides. So that means x has to be less than equal to 4. All right, so this is the first condition and this is the second conditions, right? Because we said a composite, then you need to combine, right? So you need to combine. So what is the domains here? So now we know the domains here, right, has to be greater than 0, less than 4, right? So that means x here, x has to be greater than 0, less than 4, or you can write into a 0, 4 is my domains here, right? It's very interesting, right? So, okay, now let's take a look at f functions, like the next one's here. All right, so this is the B, and this is the C here. So let's see the F composite of the F. Okay, the F composite of the F. Okay, so that means F, X, right? Okay, so the first thing, so what is F of X here is F of the what? Square roots of the X, right? So for these ones here, the domains here is what? the domains for this ones here is greater than or equal to 0, correct? All right. So this is greater than or equal to 0. Okay, so now you plug in again into the f function. So this will be square roots of the square roots of the x. All right. So if the square roots of the square roots of the x, so this will be the fourth roots of the x. So I know the fourth roots inside here, I need to check the second domain. So what is this domain here? Also is greater than or equal to 0. So you combine what is the final domain. So you combine both these conditions, right? Both of them they satisfy with the x greater than 0. So the domains here will be what? Will be the 0 to infinity. All right. Okay, so now let's take a look at the last ones here. The last one, okay, so it's G composed of the G. So the G composed of the G, so you can say the GX here. Okay, so the first thing here, you need to say, okay, so what is, oh, sorry. Okay, so what is the, okay, so what is the GX's domains, right? So we know that this domains here is what? Is X has to be what? Less than or equal to 2, correct? Right, from the GX, right? Because GX is 2 minus X. So this is the first domain I need to concern. Okay, now in here, I have a GX in the G. So I need to replace the X with G. So what is here? This will give you 2 minus what? 2 minus, the GX is square root of 2, right? So 2 minus X. All right. Okay, so this is my second one. I need to find the domains here, right? So this is my second one. So what is this one? That means the 2 minus square roots of the 2 minus X has to be what? Greater than or equal to 0, right? All right. So that means the 2 has to be greater than or equal to the 2 minus X. Now I squared both sides, so it's greater than the 2 minus X. All right, so here, if you simplify that, so this will be X has to be what? Greater than what? Negative 2. You see here? Okay, so X, so this just solve the inequality. If you don't know how to solve the inequality, you just basically, you can like move the X over, so this will be the X is, so you add the X both sides, right? So your X plus 4 greater than or equal to 2, then you minus 4, right? That's what you give X greater than or equal to 2. Okay, so now this is your second domains here, right? So it's X has to be greater than negative 2 and less than 2. So the final, you need to combine, right? So combine. So what is the domain here? The domains here will be what? X has to be greater than negative 2 and less than or equal to 2. Or you can use the interval notation, will be negative 2 and 2. Right? So, okay, so it's very interesting. Okay, so be very careful. Like I said, the most important part for the composition of the function is to consider the domains, right? So the key things here before we go to the next topics, make sure, right? In here, so you need to be careful, right? So the first one, you need to make sure this domain work, right? And then the next things here, you need to make sure the domain, after you get the domain, the range of the GX here will satisfy the domain of f of x here, right? So that's why they say here is the f of x here, right? The both need to be, and oh, what is this one here? Okay, so sorry for that. I don't mean to cancel that. Okay, so here, right? So here, right? So this is the both need to be satisfied, the f of the gx. Okay, all right. So let's take a look. So this is very, very important. So now let's take a look at our example number 4 here. So example number 4 is the composition of the 3 functions. So this is a pretty, this is not hard at all. Basically, if you can write it into the correct way, right? So the most right one is always go inside. So this is what here? So this is f of g, and then what? And h, right? X, right? Okay, so the first thing here, the most inside is h of x, right? Okay, so now let's rewrite this one. So we don't even, so this is f of g, inside h of x is x plus 3, right? So that means now you're looking for the function gx. Gx is here. That means every x here, you need to replace with x plus 3 here. Okay, so now I have this f function still out here, right? Okay, so that means everything in the g, the x need to replace with x plus 3. So this is x plus 3 to the what? The 10th power. Okay, now you see here, this is what? This is inside what? This is inside f of x, right? That means everything, every x inside of f of x need to be replaced by it, by this one's here. So let's see here. So this is the numerator is x, so I replace by the x plus 3 to the 10. The denominator is x plus 1, so I say x plus 3 to the 10 plus 1. That's it. Okay, so the number 5, okay, this number 5 is like try to recognize which one is which, okay? And the number 5, this type of the problem is extremely useful when you take the calculus. And so the reason why this is useful in the calculus is because in the calculus, when we talk about the chain rule, right? And then you will use the composition of a function. So you need to recognize which one is the outer layer, which one is the inside layer, right? So now let's take a look here. They said the f of x is equal to the f compose g's here, right? So I know the compose, that means f of what? Gx is here. That means if you put whatever, this is the gx, right? So into the f function, it will give you these functions here. So now by comparing it, so I know, so my gx, I can assign to be the x plus 9. Then the f of x, because it's inside of these roots, right? So I can say that it's x to the 4th roots. So if you don't believe, we can try to check it. So this is the g-axis, right? So the first thing here is x plus 9. So this is x plus 9. That means you put everything here. So that's why this is x plus 9 to the 4th roots here. And that's it, right? So okay, so this is a very, very important section about the composition of the functions here. I think the mechanical part is pretty easy. Basically, you just need to know which ones go to the inside, the most inside inner parentheses, and then you kind of gradually break it out. So remember what is the most important concept is the domain concept, right? So the domain concept is very important. That means you need to satisfy the domain for the inside parenthesis function. And also that the domain has to satisfy, after you combine the names, right? Okay, that's it. And like I said, this is important sections and you're going to use it a lot. All right, so in the later sections, also in the calculus. So make sure you get a fully understanding about what is the composition of the functions. Okay, nice to talk to you and you have a nice day. All right, bye.